So I've obviously done a bit of research about you. I do it about everybody I interview, and I know you started coding games at 12, and then you eventually went on to become a musician, and then somehow you did again a 180 and you joined Consensys. Sort of how did that happen? How did you join Consensys? Why did you join Consensys? Why did you turn around from, sort of, I guess being a musician was your dream?
I think at one point, yes, for sure. Yeah, I'd be happy to just dive into that. Yeah, I mean, I think so. My whole family's musicians, so for me, it's very like very natural to want to do that. My dad's a musician, my sister's a musician, so for me, it was very easy to slide into that. During high school, that kind of time in my life. But yeah, I mean, initially I wanted to do music, but I also loved working with computers and particularly doing game development. I think it was like a magical time for gaming, quite frankly, because that was like what time would that be? Maybe 2008 to 2004
Okay.
era was such a great era for different games, and then coming off of I think some of the earlier games before that, even like early 2000s, late 90s games. The titles for everything were great. Like I think everything was pretty magical. So, you know, um, also love doing coding and games. So for me, it was always a split between music and coding, and then eventually coding always sort of like paid the bills, you could say,
Yeah.
but then eventually started to pick up more stuff related to Bitcoin, more stuff related to crypto, and got more interested in that than wanting to mine that, and do that sort of thing. And then from mining, wanting to work with it. So there was sort of an evolution from sort of away from games into, um, kind of the crypto space and crypto system, and that sort of came about because I think after 2008, I think my dad sort of started to
Yeah.
feel like maybe things aren't the way that people tell them, and maybe he should look at alternatives and stuff. And then you kind of go down the rabbit holes, you start looking at different things, and then eventually crypto was something very, very new. Initially I thought it was just like a scam, or like
Yeah.
some kind of weird thing, and I wrote it off. But then later on sort of discovered it again, and thought, okay, there's something interesting here. And then yeah, so my early days with crypto started with mining, and then from mining trying to build something on Bitcoin, and then that was a disaster at the time. It's very strange time. It's weird still seeing like 10 years later, or whatever, like stuff regarding like the op return opcode or whatever, like these like fabled opcodes now that Bitcoin has,
Yeah.
because like when I was fooling around with Bitcoin, like I was trying to, you could probably in the archives find my one forum post in the Bitcoin forum where I basically say we should expand the op return from 40 bytes to 1 megabyte so that we can like do things with Bitcoin, like put code on there, like do
Yeah.
something. And like this Bitcoin forum just blew up in like a hell of a rage. And then that's where I sort of I discovered Ethereum after that. And then started to go to Ethereum meetups, started to meet some people there, and then and Ethereum was like pre mainnet. I don't even know if it was in testnet when I first discovered it. It might have been. There might have been a testnet running, and then started to work with Ethereum at a very early stage. So started to meet a lot of people. So I don't. It's not like a lot of the early Ethereum people are like my best friends or whatever, but I know them by acquaintance quite well. So I know some of the super OGs,
Yeah.
and yeah. So then started to work with Ethereum, started to build on it. I was probably one of the first builders for Ethereum, first users of Solidity, one of the first users of like whatever the hell the tooling was
How
at the time.
how
Yeah,
was Solidity back then? I
that
remember
was
when I first
terrible.
started. Yeah, I remember when I first started coding Solidity, maybe 3, 4 years ago. It still felt rudimentary. I
Yeah.
can't imagine back then.
Well, okay. So first of all, I mean, I think that like there's a lot of context to Solidity that people miss. Like you know, it was initially started by Gavin, who everything Gavin ever built for me was just like a giant problem. Like it was always breaking, everything was overflowing. He'd always write in C++ because it was pre-Rust era. And his client would overflow like everywhere at random times all the time. And he could never ship it and it never worked. And then Jeff, who was working on the Go Ethereum client, like he shipped, and got that out the door. And and they both had the same amount of material to work with, which was like the white paper, the yellow paper, Python stuff that, you know, Vitalik was working on. And then basically Jeff was able to ship it and the Go Ethereum client is the like de facto client
Yeah, yeah.
for Ethereum still. And it just is like a huge testament to Go. Like whatever you want to shit on Go, like
I wanted to
Go
say,
gets it done. Go is
yeah,
made by like Google networking people who didn't want to write in C, and it works. So like people shit on Go all the time. I'm like, I don't know. I'm like,
it's productive. It's
it's very
productive.
productive and it doesn't change. And like after running now like a Rust shop for so many
I
years,
wanted to ask what do you think about the recent craze with Rust versus Go?
well, I mean, Fuel went very hard into Rust, so like I can't shit on Rust too hard. I do really like Rust a lot. I think there's a lot of really nice things. And I think for social coding, there's a lot of nice things there. And it definitely makes all the language improvements you sort of want. And it's like it's super intense as a language. But I think the problem is, at least that I see, in terms of like real code productivity, sometimes I do feel like other languages, despite being maybe technically worse languages, are for some reason more productive. And it's
Yeah,
like a strange thing that humans are like somehow more productive with like TypeScript and Go and
yeah,
Python, yet languages like C++ or Rust have so much more facility and control and checking, and yet it always feels like an uphill battle. So I mean, I think what I've seen with Rust is like it's an amazing system, but it's also has its pitfalls as being something also pretty complex, and the complexity alone just I think has a big downside. So I think that that's like the reality. But as like an upgrade from C++ and all these other languages, it's like a
yeah.
massive.
Fair,
And then
fair.
I think like more of my favorite stuff now is like I think Zig is probably my favorite like middle ground between C and something, and like I think it like meets a lot of my like ooh I like this a lot kind of criteria, but then it also will have some it's not as tooled and as robust as Rust. So I think like Zig
Yeah.
falls short here and there.
Well, it's hard because it's obviously everything that's young. I personally, in sort of my work, I try to avoid anything that's young. I just try to not even look at it, no matter what I see on Twitter, how
Right.
crazy amazing it is. I just don't give it. Obviously, this is not good for the industry that people like me don't give attention to new things. But it keeps me productive and it keeps me safe and happy and not frustrated, which is sort of a bigger gain for me.
Yeah. No. No. Totally. I mean, I guess for me, I find myself autistically rabbit holing down the wrong new thing all the time. And I think it's sort of part of my creative process. And sometimes it's very useful, and you pick up things way before everyone else. And like, depending on how well you can execute over that, I think like there's like, a range of benefits. But as well, it also means that like you go down a lot of rabbit holes that are like nothing.
Yeah,
Get all the way down to the bottom and you're like, fuck. So even with Zig, it's kind of like you go down, you get excited, you're like, oh, okay, there's a lot of nice things here. Like I actually like a lot of this. And then you start kind of plotting out like, well, if I were to use this, like what would I need and what would I have? And then that's where things get a little tricky. And then you start looking at the libraries and you're like, this crypto library
yeah,
doesn't feel like it's really been kind of locked in. And then I'm like, okay, well, that's a tricky, sort of situation. And then what's funny is like, so because I've rabbit holed that, I kind of know that piece of information. And then now when I look at like Solana doing one of their clients in Zig, all I can think about is like, but like there's some pieces missing. Like
yeah,
it would probably make it pretty shitty to build with this thing. And then, the fortunate thing with Zig is you can always like bring in C and some other stuff into it. So like you can kind of supplement it, which is really nice with probably like really robust stuff. But like nonetheless, it's sort of like I think that when you rabbit hole a little bit, you kind of get some more information out of it that like maybe most people don't have.
True. I mean, it's like whenever you build anything that you don't yet know, like there's the planning phase when you do research and you ask people and you figure out the architecture. And then there's the actual prototype where you actually learn all of those small nuances that you couldn't have figured out without
Yes.
actually writing code.
Yeah. But yeah, maybe to get back to, I think we sidetracked here quite hard.
No, it's
So to
fine.
get back to get back to like where I started, yeah. So like started to work with crypto more, and then effectively, Joe from Consensys, he found me on the Ethereum forum, and then I started talking with him, and like he basically, I mean, he just started paying me even without a contract or anything. Like just he literally just started sending me money. It was like he sent me Bitcoin, and quite frankly, like when that first happened, even for me, I was like, I don't think he can get this back. Like I don't fully understand Bitcoin yet, but I'm pretty sure he can't get this back. Like I'm just a random guy on the internet just YOLOing, paying me, and I thought like, okay, well that's sort of interesting. And then I started to work with Joe and Consensus a lot more, like sort of
Can
formally
you can
joined.
you tell us what amounts he was paying you, or is
It
that
was just
too
yeah, just like small contractor wages, like 5K a month or something.
okay?
But it was not nothing, but it was also
Back
like
then, that's pretty
yeah,
good.
yeah. And I mean, the crazy thing is like at least with Joe and at least like with Consensus, the thing that I liked about early Consensus and early Joe, because I think Joe goes through many different phases. I don't really know
Easy.
Joe now, but the
Okay.
Joe that I knew for the little slice of time, was like a different person, and he basically like what I liked about it was really trying to bring together lots of interesting different people to build the social layer of what Ethereum was, because there wasn't anything, there wasn't any really support other than like some enthusiasts, right, trying to do things. So, like early Consensus really kind of brought that together. Let me just make sure we're connected here. I think it's still
We're
recording.
good. We're
Yeah,
good.
it's good. Okay, I think your picture paused, but okay. Yeah.
It's
So,
you talk about phases. It's very interesting to talk about his phases, but I imagine you also went through a lot of phases as well,
oh,
from
100%.
being just some random early Bitcoin miner to then coding this thing to then now being the founder of a pretty successful and pretty big network.
Mm. Yeah, I mean, what I would say is that like what I was working on with Consensus was like some of the early apps for Ethereum. So like one was a crowdfunding app, so doing like token launches, and the other one was like a governance app, so doing like voting and DAOs and that sort of thing. And that's like where I started, was building these kinds of like apps on Ethereum. So Consensus was like a good first pass, I think, at like trying to run those projects and like learn some things there. But once I left Consensus, and after I left, then I sort of started Fuel. And Fuel was really different. Fuel is like more something that came about, I think, because I was seeking better infrastructure for Ethereum, and initially just wanted to make something like a wallet, something that could, have Ethereum security but be very, very fast. And I think like that kind of leads you down a bunch of rabbit holes, and then you eventually kind of find roll ups and layer twos is like the technique that makes sense. And again, because I rabbit hole pretty fast and pretty hard, I think that we were the first actual roll up to Ethereum, the first actual one to deploy to production and sort of meet what we thought was like good security standards, and basically push that out. And I think the core idea there was like I really liked Ethereum, but I wanted it to be faster and more scalable and actually solve some of these other problems that
It's a common problem. Yeah.
yes, yeah, exactly. So, so that was like the initial intention, and then so we shipped Fuel V1. That was like December 2020, and then Fuel kind of grew from there. So, and basically like the current iteration we have now is sort of like our massive new build of I think a lot of different things that I wanted to see in blockchain specifically, and just a lot of things that you want to do in blockchain that you just couldn't. And it's funny watching. Ethereum or Solana, these other chains, like kind of slowly pick up stuff that like we've already done or we
Yeah.
already have, basically. But I think Fuel is very technology focused, and the space is very growth focused, or it's very the space is focused on numbers and speculation, whereas like Fuel
Yeah.
has always been very focused on tech. So I think for us, like our tech's good, and now we're sort of learning the game of, I think, what healthy ecosystems need to be, what a healthy community needs to be, and like natural and organic growth, to get us to where we want to go.
I want to
So
talk to you. I want to talk to you about fuel performance. So you have uh, basically already. I've read this. These are things that you have said. I think I if you don't remember them, sorry. But you said that basically Fuel has sub 100 millisecond TX confirmations, which is amazing. It's really great. Like even Solana, I've learned yesterday when I was interviewing Doug Colkett from Ambient Finance and Fogo that Solana has like 400 milliseconds. And so you guys also aim for really, really high performance. And there's a bunch of benefits to that. Obviously, we all want faster transactions,
Mhm.
but I think performance cannot come without trade offs. We all know that. I've learned yesterday what sort of trade offs Fogo took. I want to learn what trade offs you guys took with fuel.
Yeah. So with Fuel specifically, I think there's a few things. So one is that um, there's kind of blockchain marketing, and then there's reality, and reality is always really, really complicated. And blockchain marketing, unfortunately, at least something I've learned, you kind of got to simplify, and you got to sort of speak to, I think, like, most people, and then, try to create excitement, and then you have the reality of the situation. The reality of the situation for blockchain in general is that basically, the internet only works as fast as it can work. So if you have giant peer-to-peer systems, and you try to do things really quickly in a peer-to-peer setting, it messes with the peer-to-peer nature of the system, and it can have a lot of downstream negative consequences. So, and there's different realities to that kind of speed, right? So for Solana, for example, for a user, when they actually get a confirmation back, is very different from when a block is finalized. So Solana at least has, even though it's 400 milliseconds for what they get as a confirmation, they are finalizing the block as well at 400 milliseconds typically. So that's like block finality. Now, that's block finality for the entire Solana network on planet Earth, which is pretty good. So I would say, like, for a peer-to-peer system, that's like pretty good, because to really transit the Earth
Yeah.
with the data that you need and actually come to consensus, 400 milliseconds is like just it's like maybe just enough time, given the way that the
Yeah.
internet is wired. And Ethereum actually gives a lot more breadth, like 12 seconds, because it just allows for a lot slower computers and more home verification, these kinds of things, to actually sync and like catch up and make sure that the blocks are finalized. Now, when you get into like soft confirmations, and you get into sort of pre-confirmations or soft confirmations, whatever you want to call them, that's really a different style thing altogether. That's about trying to give some evidence before the block is actually completed that this transaction is going to go in, this transaction has been executed, this transaction has some outcome, right? And having the builder actually kind of give that back. It's like a credible attestation, right? And that is a very different kind of guarantee. But as we've come to learn, both in building product and building infrastructure now, it's actually super important, because when you're building sort of high performance systems, or you're building things that run really quickly, like order books or trading engines or these kinds of things,
Yeah.
those little guarantees, or those little IOUs, or whatever you want to call them, those things are very, very important to those systems, because they need to work at a very high rate.
Yeah.
And there's a lot of parties that don't really trust each other working at a high rate. But a lot of parties will still trust the operator, like they'll still trust the builder.
Okay.
So basically, what Fuel did in terms of mediating this, and again, Fuel is a layer two, Solana is a layer one. What we do is try to mediate the two, and we try to say, okay, well, our blocks finalize at 1 second, which is more than enough for peer to peer. So the fuel peer to peer layer that gossips around, and you have enough time for gossiping blocks and that sort of thing. So our block finality is at 1 second, and then the soft confirmations from the builder are down to, especially within region. If you're within the same server cluster, you can get them down to like below 10 milliseconds basically.
All
But
right.
if you're
Yeah.
within region, probably like around 50 milliseconds. We could probably get that lower if we do some things around the load balancer, but like basically you can kind of get that lower. And then, if you're out of region, then you're just talking about sort of like at probably 100 millisecond times or greater, depending on your connection.
So
So essentially, like, it's really good confirmations for a service on the internet, like let alone a blockchain. It's probably the best you can get, but we also don't
okay.
sacrifice sort of block times and security and peer-to-peer syncing when we do soft comps. That's why we like it. Yeah.
So sort of optimistic updates by only getting your state from the local consensus.
Well, so I mean, the way that I would put it is soft comps are sort of like really, they're like very, very fast signed attestations that like your transaction's confirmed and it's going in the next block. Then, if you want to wait for a little more finality, then basically you go a little further, you wait till 1 second, and then you get that builder signed confirmation over the whole block, right? That like this is going to be the block. And then if you want more finality, you want more security after that, then you have to wait for that to be posted on Ethereum, so it's challengeable.
Yeah.
Uh, and then after that, then you have to wait the challenge window, which is currently so it's set to 7 days. If you're in a ZK rollup, it would be when it's actually proven back to Ethereum. Yeah.
So then it's all sort of what's the risk appetite of the user. Now the question really is, do you guys have any sort of statistics on how often you can, like, what's the sort of a confidence interval of how often should I trust this number if it's within this amount of confirmation or within 1 second or within so on and so forth?
Yeah, so I mean, I think that at least what we see in sort of the application design space for blockchain and like for dexes things like that, I think if you're building a high performance dex or app, then those soft confirmations are great. I mean, they really power the whole system and they help actually everything work well. And so for gaming or like high performance trading, they definitely want it down at like the millisecond timing if they can get it right. But if you're talking about something slower, like say something where you're not really so time sensitive, maybe like opening some kind of position or taking out a loan or something like that, then definitely you can wait a little long. You could wait to one
Yeah,
second. And like 1 second is pretty amazing. It's just
it's
in
good.
finance or in gaming, 1 second is like an eternity. So
Fair, fair. I'd really love it if you guys actually had stats on how often that 50 millisecond gets reverted or how often that 1 second gets reverted. You probably don't know them off the top of your mind, even if they do exist.
I mean,
But
it's likely the case that at least in a single builder context, that you'll never see any reversion there. There's not that doesn't really happen. I think that you see sort of uncling or reversions or other things or kind of going back on blocks more in a consensus system that is a little softer. So if you're not using single slot finality like Tendermint or Solana, for example, or these kinds of chains, then basically then you have sort of some soft reversion area, right? Like Ethereum might within the epochs revert
yeah,
to some time. So basically, but with a layer two, especially with a layer two where we're at, with an operator, it's like you're not going to see reversions. I think the whole point of giving out the soft comps is actually that confidence that like this is going to go through. So unless you have like some kind of crazy bug or like a power outage or something like that that like took the builder down and then they didn't come back and reproduce the block that they wanted to somehow, then yes, that's a problem. But even the soft comps they issue, they can store locally, so that shouldn't even be an issue. If it's
yeah.
restarted, it'll still just continue as normal. So it's actually pretty robust. I think the case where you would see bad soft comps before the block is done is a bad builder. So maybe you have a builder that isn't gossiping correctly, their soft comps, or you have a builder that's like specifically malicious, trying to
Yeah.
issue bad soft comps. And then in that case, then you could see a bad soft comp into a block. But it's very easy to slash them. It's very easy to have pretty deep consequences for that. So I think that you can kind of mitigate that pretty significantly.
My camera
Yeah.
went down for a moment, but I'm still here. I'll try to fix it while I get you talking. This is super interesting, and I think I got my questions that I wanted to ask you, except there's one other question. I've read that Fuel does parallel transaction processing. How does that work, especially in the context of race conditions on like smart contracts?
Yeah, yeah. So basically, Fuel got the benefit of, again, sort of designing in hindsight, right? Like we looked at all the different chains out there. We looked at a lot of stuff that was designed before, so we got a good sense of like the ultimate design properties that you want to incorporate into a chain. And one of them is being able to use all the threads and cores of your CPU to or GPU to validate the chain itself or to execute the block itself, right? And so basically, when it comes to transaction execution, there's a few different things that we do in terms of parallel execution that are quite important. So um, basically, the way that I would describe it is you have all these incoming transactions, and you want to be able to kind of build blocks in parallel, and then you also want to be able to validate blocks in parallel. So validation is just as important as execution. Execution, however, though, because builders typically use bigger machines, maybe they can get away with like a really good core, and they don't need so much parallelism. But if you get heavy load, then you're definitely going to want parallelism for sure, and you see that with some of the later blockchain designs in the space. So, in terms of how Fuel's design works, essentially we use a transaction model that allows us to see kind of what's coming next in terms of state changes. And so you get to have this sort of advanced notice to say, like, okay, this transaction is going to touch these areas of the chain, these transactions are going to touch these areas. And if these transactions don't cross the same area of state, then we can break those up into different threads, and they can be processed
So
differently in
in
different
rough,
ways.
simple explanation terms, you just basically try to prevent the same smart contract or the same system being touched at the same time, and everything else can be parallel, which
That's
makes perfect sense. I think this is similar to what Solana does too, right?
It's similar, but Fuel uses a bunch of different additional techniques that I think are a little more interesting than what Solana does. So we go a little above and beyond just parallel execution. So essentially, we can, just by looking at the transactions alone, kind of understand which transactions are going to touch what. So then you can parallel process that and kind of move the chain along. But additionally, we also have a transaction model such that there are programs within that transaction that are kind of like mini programs. And those mini programs are isolated, they're like monotonic. And so you can actually not only parallel process the transactions themselves with the field transaction model, but you can actually also parallel process different programs within each transaction. So imagine, like in Ethereum, if you could write a mini program inside of the broader program, and then the client could actually take all the mini programs and put that on one thread to go and process, and they could go and process all this other stuff. And they don't need to care about when things process or when they don't, basically. And so in our case, those are called predicates, and those predicates you can parallel process in addition to the transactions. So we actually have multiple layers or multiple optimization pathways for parallel processing in the chain itself, basically.
Makes sense. Makes sense. Give me one more second because I think I figured my stuff out. Um,
No worries.
can you see me? It's still weird. Trying
I
not
can
to
see you, but it's just like a
trying
single frame
not to
of
show
you.
you
Yeah.
my messy bed, basically. Uh, as much
Yeah.
as I can, at least. Okay, super interesting. I basically, can you explain? So you used word to explain how this is different from Solana, and I didn't quite get that. What I did get is that these happens in parallel. They don't touch obviously the same program, but then they can basically process different things in the same transaction, which is super interesting because that means that obviously the transaction can go faster, but also like I want to understand how that actually works because it sounds risky, it sounds dangerous. Like, how do you know what in that transaction can happen in parallel and what can't?
Yeah. So by design, we've already factored in this sort of race condition situation. So there's no given the way that the transaction model works and the way that our execution model works, there should be no there's no by design chance of what you would say is a race condition. So that doesn't happen. And the reason why is because when we have these sort of mini programs, they're designed to be stateless. And because they're stateless, it means they don't actually touch or manipulate any state. They're just either true or false. And so when you have these mini programs inside of your transactions called predicates, these simple true or false programs where it's just some execution, they just return true or false. If they return false, the whole transaction is invalid. So basically, you just don't include that transaction. If they return true, you include that transaction and you continue on processing that transaction. And so, because you have this sort of binary outcome, it means that by design, you can basically just look at all these transactions. You can then do all the parallel executions. You can pull all these different predicate programs out. You can then put that on a thread and execute that. And then you can go and do all this other stuff too. You could start loading up all the UTXOs that are being touched. You can load up all different pieces of the transaction. And then basically, this just allows you to segment the different levels of execution. So you can actually, either execute in parallel or you can actually verify everything in parallel. And in this particular effort, actually, is really nice for verification because what it means is you can just take a look at a block, you can see all the different predicates that are in there, and you just know you can just extract all those, pull them out, parallel process them, and then also execute all these other transactions, verify all these other transactions. So you get this really nice ability to do multiple levels of parallelism, not just over the transaction level, but over within the transaction
Okay.
itself,
Is
basically.
this
Yeah.
potentially related to why you guys have even chosen to make it and build your own language?
Yeah, exactly. So because Fuel is, again, it's a blockchain first architecture, it also means that a lot of the program design for what it is also blockchain first. And so that's why having like a specific language that can target these different environments and also factor in the different ways that these environments works, like predicate execution versus script execution, versus the way that like writing smart contracts is or writing libraries are. Each one has a different sort of program style, and so having your own language allows you to basically target these different specialized areas of execution, and that again gives you that's where you actually can get the interesting optimizations and interesting performance benefits by adopting and trying out these kind of different models and not just falling back on like the typical models you see, which is effectively just
Yeah.
like smart contracts. Fuel has many new ways to do things
I have a
outside of
bit of
smart
a love
contracts.
hate relationship with both sides of this coin of building your own language or not. Because on one side, like for example, Solidity and all of the other languages that have been built for smart contracts lately, well, like why we have already very mature, very good like languages that are proper good languages like Go and Rust and so on and so forth, and you could use those for smart contracts, and there are benefits to that, but particularly the fact that they're mature languages. But on the other side, I've been coding for the past 6 months Solana programs, and like so many foot guns, so many issues with the libraries, so many problems with the proc macros and all it's driving me insane. Granted, I'm not a Rust expert. This is my only Rust experience, so could be me, but I don't know. It wasn't easy always.
Yeah. So you basically described both the biggest pitfall of doing your own language and also the biggest benefit. So yeah,
Thank
well,
you.
well done. Uh, yeah, I mean, effectively, that's why we built Sway in the first place, is because it's like, in theory, Rust should be able to target your system. It should be able to write all your smart contracts, and then you go and
Mm,
do that,
yes.
and it's horrible. And then try to do it in C, and it will also be horrible. And try to do it in a different system language, and it will also be horrible. So it's like, can you use a systems language in the LLVM pipeline to target your blockchain? Yes, you probably can. Does it result in a really good developer experience? Likely not, because those languages are systems languages. They're designed typically to target hardware and CPUs and computing environments. Now, blockchains are computing environments per se, because they're like virtualized computers, but they work very differently to a lot of computers. And so the side effects are pretty tremendous. And that's why you need so many band aiding and bootstrapping on the language side. And that's why having your own language is like amazing. So if you look at Sway, it's like the nicer, fun parts of Rust without all the baggage. And then you can just sort of like do things as if it were Rust, but as well have an actual language is going to target the system correctly, like with all the proper standard library, the proper tooling, like the proper targets and systems, and you don't need any of those weird
I'll have
macros or
to
anything
try
like
coding
that.
something in Sway before I say anything about Sway. But sort of
Yeah.
the problem that I see is that now you've just added a lot of work to your team. And
Hmm.
also you're in a race because you have to move fast and implement language
Hmm.
features. And like, to me, it feels like, okay, there are benefits to it, all of the ones you just said. Also, it's work
Hmm.
and you have to find adoption. It's one more thing you have to market. From a business perspective,
Hmm.
I think I don't like it. From a developer perspective, I think I like it.
Hmm. Hmm. Yeah. So I mean, it's definitely one of the harder things to always do and keep pushing. I would say that if we weren't in the position we were in now with Sway, I would be probably more concerned. But where Sway is today is very good. I would say it's like, and it's improved a lot even recently as we've pushed it harder on the application level. So for me, like, Sway used to be, I think, a risk, but now it's a
Okay.
lot less of a risk because the language has hit at least a decent level of complexity and maturity, such that I think you can kind of get everything done that you want to get done with it, and it's not too complex. And I think similarly, like the Noir people are also going to be in a similar boat, essentially. But I think we have enough resources and people and time to be able to kind of push it forward. And the alternatives really do suck. Like basically, the alternatives would be that we would have to either interpret something like WASM or RISC or whatever into our VM, which would have obviously a lot of downsides. And then, and or we would need to actually fit the LVM pipeline on top of our system. And that also is a lot of work to maintain. Like, you want to talk about maintenance. It's like just maintaining the LLVM target to target our VM also takes the same amount of devs as probably
Okay.
building a compiler.
Fair. Fair
So,
point.
like, so what I would argue is like, and then you get the worst result of
Yeah.
like, now I have this systems language that I don't like using on it. So it's like, you're right, and Sway doesn't really make sense from a business perspective, but like Fuel doesn't make any sense from a business
Okay.
perspective. It's actually all kind of an oddity. The whole point is more or less that like most teams and most people don't actually want to do anything different, and because they don't do that, then they
Yeah.
never progress the space. They never find what the real end game is going to be. It's always just like EVM copy and paste, iterating over the EVM. Like it's the
This is
same
the
thing over and
rabbit
over.
hole versus me not trying new things, because this is
Yeah,
the basic core problem right here.
yeah, yeah. But I think that like what's exciting is when you really get into the interesting use cases, and I mean the ones that like are the more cutting edge that you see in the space right now. So like trying to build hyperliquid or trying to build like a really high performance DEX, right? Or like a really high performance game. I would not want to use the
Yeah.
EVM at all. Like that machine is a disaster slow. It's horrible fast. Like it's just like the amount of debt you incur just using that system is awful. And so at least with fuel, because we have all these different pathways, whether it's at the transaction level, at the execution level, like the VM level, the different kinds of programs we have, the different kinds of options we have, and as well the ability for us to design new kinds of transactions, new kinds of inputs, or these kinds of things. It means that if you want to go build Hyperliquid 100 times on a single chain and actually have it all work, all be composable in a high performance setting, you could do that on Fuel. But you can't do that
Yeah.
on an EVM chain. Like it would just be, it would suck a lot, you know. So basically, that's kind of the difference, I think. And only when you really push things to the extreme do you start finding that kind of reality, I think.
Fair.
Yeah.
I want to ask you, since we've gone a bit out of the tech and a bit more into the business of it.
Hmm.
Well, actually, so one of the drawbacks business wise that I mentioned was obviously the extra work, which you've sort of countered perfectly, I would say. But the other is
Yeah.
the marketing of it, because you have to convince devs, lazy devs like me, to go out there and
Hmm.
actually learn something new. And not ever like you
Hmm.
are obviously a rabbit hole type of guy. Not everybody is, unfortunately. Um, so how do you sort of tackle that, and how do you tackle the marketing of the language and all of that?
Yeah, I mean, I think that's something that we're constantly trying to figure out and learn all the time because it is really difficult to push something new. It's very difficult to push something different for sure. I think the way that like we kind of counter that and also try to actually do a good job. One is that we've started to basically try to tell the story of the different pieces of the language and try to do that really consistently. So in the marketing side, I think we just want to try to keep putting Sway out there and making sure that people understand that like this is actually a very interesting and complex tool that works really well to design high performance programs for blockchains, and basically try to get a dev to feel that. And I think that there's a lot of things about like development, but I think one thing is like emphasizing that initial feeling
Yeah,
that you get when you use some of these tools. And I think you want devs to have like a really good initial first pass and first
I
take.
agree.
And then it sort of doesn't matter what the rest is. Like you just become kind of fascinated with it. You know, you become fascinated by what it could be or how it actually is. And I think that's where you get into really sort of heavily nerd sniping people in a way that is like very effective. So on the marketing side, I mean, I think that we're focused a lot on trying to tell the story of what we've done and the story of Sway specifically. But on the actual like results side or ecosystem or delivery side, that's like a little different. And on that side, that's more about founders and more about trying to bring good teams into Fuel and trying to build a different style ecosystem, and one that actually can leverage all these different systems. And I think for that, that's going to be also an uphill battle, but it's an interesting one where I think you really have to focus on the
Okay.
founder like a lot. And I think the first pass ecosystem that we had a lot of projects that have been building with us for a long time. Some of them made it, some of them didn't. It's a natural course. But I think that for the next wave of Fuel projects that we want to welcome, we want to try to put out sort of like the feelers and the right messaging to say like we don't want people that are kind of part-time or just like not, they're not fully invested. We want people that are really kind of quality builders that want to push the space forward. They want to try new and interesting primitives that they couldn't before, and then they want to actually grow and build interesting businesses on Fuel. And I think that's like it's a different kind of net that you're casting there, and you have to be very intentional about it, and it's going to take a while. But I think that like that's where we'd like to head, because I think that when you look at the amount of work it takes to actually get a high performance system running in general, Fuel takes out a huge amount of work in doing that if you can leverage it properly. And I think that this will be sort of one of the infrastructure keys to Fuel actually succeeding, among other things like getting bridging to be really solid, supporting all the wallets really nicely, making that UX and that flow really seamless so that a user doesn't even know it's Fuel. It's just sort of like a super high performance app. And I think that's sort of the next level for us to try to get to there. And then that's sort of the other side of it. So there's kind of like the Sway and developer story, and then you have kind of the founder story. And I think both of those need to
The
be
developer
told.
story makes perfect sense to me because as a developer, with my recent encounter with Solana programs, I can tell you straight off the bat, it just felt wrong. It just felt bad. I didn't love it. And I already catch myself sometimes being biased against both Anchor, Solana, but also against Rust. I'm literally now biased against Rust. I've got myself in a discussion this week feeling that way, and it's all because of that initial feeling, not because I have any sort of real objective arguments. And
Yeah.
going back to the founder story, I think I have a quote of you where you said that you advised basically founders to have unwavering faith in their projects and to persevere. And I actually wanted to ask you about
Yeah.
this because it's very hard being a founder. I haven't done it, probably particularly because
Hmm.
it's hard. You've been at it for a long time,
Yeah.
and probably now it's not as hard because you already have some momentum and some success to a pretty good degree, I would say. But how do
Hmm.
you cope with all of that? And sort of, I think this can also be important for your messaging as well.
Hmm. Yeah. So what I would say is like, um, I think like as a founder is kind of pushing through the hurdles. Like initially, it's really really tough. I think there's a lot of unknowns, and there's a lot of things that get sort of
Yeah.
thrown your way that really suck. But then you sort of learn over time, I think, to grow thicker skin, and then kind of push through a lot of things. And then you also learn how to deal with, I think, people better. You learn how to manage and how to execute better. So I think it's all a matter of just trying to continually improve. I don't think anybody though is like fully formed when they just kind of get in. And I think every kind of startup, every kind of project, every kind of thing is always a different challenge. And even for really seasoned people, it's always a challenge. And I think it's just like, it has a way of always throwing crazy curveballs at you. So I think you just learn over time to deal with the unknowns, and then just try to continue to progress and continue to improve each time. So I think it's always just about trying to improve, basically, because you're never going to be perfect, and you're always going to make mistakes. But so long as you're on the trajectory of improvement, I think it's okay.
Yeah, that's
Yeah.
still sort of, it feels easy to say and hard to do, like emotionally and mentally. uh, It just feels like, for example, me, I have a cushy job, I have a good life.
Yeah.
I want to, I feel that itch, but also I'm risking so much, at least in my mind, I'm risking so much. It's hard to cope with, I think.
Yep. Yep. I, I think that like I think people definitely handle risk differently.
Yeah.
Different people handle it differently. I think for me, I haven't. I guess I haven't been so against trying to take a lot of risk and try to do something interesting. Like I think it's more exciting, and it could potentially generate a much better outcome for a lot of people. So for me, doing something interesting is better, I would say. Um, but then again, I can
Yeah.
totally see the other side of it. And I think it's like definitely cost me health wise significantly to like do these things. So it's been really negative
I
physically.
hope not too
But
bad.
not too bad, but it's definitely like it wears on you for sure.
I can imagine. Hopefully, maybe someday I'll find out. There's one more question I have for you before I let you go. But if you have no more time, we can cut off right now.
Yep. I don't know.
Like,
Let's do it. I think I have a bit of battery
okay,
left, so I think it
great.
should be enough. Yeah.
So you've been at it for a long time. Obviously, you're not the only network in the business. You're not the only person or company that's promising a really fast blockchain out there. Um,
Yep.
who do you think are your main competitors, and why do you think you are better? I know it's sort of a maybe a loaded question to ask, but
Mhm.
I think if you didn't think you are going to be better, you probably wouldn't do it. That's sort of the goal, right? To do better than at least most people.
Yeah, yeah. Well, I mean, so I mean, if you're getting in the weeds of like product and startup and business and all that sort of stuff, then the word competitor and the people you compete with are like squarely a reality, right? So I mean, initially when Fuel started, the competition was like Arbitrum
Yeah.
and Optimism. Like that was like a long time ago, but that was like the initial competition, like ZK Sync. And it was sort of the competition in the sense that, like, well, obviously rollups were new and they hadn't shipped and we hadn't shipped, so it was a whole thing. But I think as the space evolved over time, like I see them way less as competition, like way way less, because they're really serving a very different purpose than what Fuel would serve anyway. And I think that in terms of progressing the space and also actually doing something interesting, I think that Fuel's competition, at least right now, is going to be like infrastructure providers for centralized
Okay.
exchanges, for example. Like literally the people building infra for centralized exchanges or the centralized exchanges themselves. I think to me that's kind of like a bit more of our actual competition. And I'll sort of explain why. Like I could say our competition is like high performance layer twos. So like, Mega ETH or Hyperliquid or something like that. But I actually think that that's kind of like a narrow view. I mean, I think that you can kind of get into the nitty gritty, but I think that in terms of being a global trading layer or something that's actually going to power a lot of trade or a lot of movement of assets, a lot of settlement. I think that Fuel actually it doesn't have a lot of competition because there's not many systems really like it in terms of its transaction model, its paradigm, the way that it's built. But I think that it would be more trying to supplant all these centralized venues, centralized exchanges, or what you would call like unverified venues. So, because even Fuel uses some centralized components, so I would say unverified computing that's going on. It's just like a
Yeah.
black box. So it's like Nasdaq and all these centralized exchanges. They're
Yeah.
like total black boxes. Like you put money in them, you hope they do what they're supposed to do, and then you take it out. And it's just sort of like it kind of works on trust, and I think that's actually what we're both trying to end, trying to compete against, and also trying to really actually replace. And I think that crypto can get there, and I think that blockchains can get there, such that all of those systems, those like really fast financial systems, can all be replaced with really powerful execution. And I think that Fuel actually has a really good shot at being that model. And it's just a very different service area than what you would do with an EVM typically. And EVMs are just so bulky and baggy that like, we can leave Ethereum and the EVM chains to like deal with that system. I think that we want to go after a much higher performance bracket of systems, and I think that those require a different kind
No,
of
I totally
technology
totally
and
see what you're
decisioning.
saying. Basically, the answer is we don't have to compete against the other L2s because where's our pie, all of us, is still so small, and there's a bigger pie out there. Our pie is going to grow because all of these other things will just not be able to compete because they might be fast, but they're not centralized. So as soon as we fix speed, all the capital is going to converge into decentralized. That's sort of the bet here.
Yeah, exactly. And I think you can kind of like break it down like Bitcoin is kind of like digital gold. Ethereum is like,
Yeah.
settlement, you could say. It's like Bitcoin is like savings, Ethereum is like settlement, right? And then I think Fuel is execution. And I think that the execution bit is the one that's still an open question. I think that's the one that actually is where a lot of business gets done. And it's sort of in advance of final settlement, like Bitcoin or Ethereum. And I think that's where Fuel actually has like an incredible window to basically be that end game for
Makes sense.
execution.
Makes sense. Well, this is it. Thank you a lot for coming on and talking to me and answering my questions.
Thanks for having me. It's great.
I hope you
Yeah.
also enjoyed it. And well, that's about it.